We hooked up the vacuum hose on the diaphragm actuator, vacuum actuator here, to pump, and we're gonna try to test if the wastegate is working fine, because I had an issue with that in the past where it was there was a bad wear on the leverage here of the axle. So we're gonna try it. Yeah, that seems to work pretty fine. Because in the past the leverage here was shifting from side to side. So now that we have it in the hands, it's better to watch it. So that's good. So we're gonna release it, and then we're gonna try the other one to make sure as well. Yeah, that works magic. Perfect. Go. Yeah, that seems to seal pretty good. And if we look from the side, make sure that the axle is still good. Yep, no shifting from side to side. That's perfect. Check too quick on those. You can see there's some white on one side. The white is because the it's a leak of the exhaust pressure. So when we close it, we can see the valve is shifting, and also there's a play from side to side. You can see the play. Make it move to see with the vacuum pump. You're gonna see when it sits, it's shifting, and then there's a leak happening. Yeah, we saw it move again. Yeah, we shift from side to side. Okay, so I'm gonna have to remove them and get them to rework. The other one is the same. You can see there's some white there. There's some play on side to side, and it should not be. So I'm gonna send these for rework. I'm gonna remove the turbos from it and just send it to rework. Looking at the crank itself, we can see that the diameters of the crank are very good condition. No looks like brand new actually. No special wear. Can tell all of them are pretty good. So this is just right. Actually, I never had a crankshaft that was so worn that you can. I see that on other cars where you got like the bearings that are being tear apart on the on the crankshaft journal. Never had these. So yeah, crankshaft looks pretty good. Now it's time for inspection. So we're gonna use telescopic gauges. The way it works, I guess you guys know about that. You just put it in the hole and then you release it. The idea is to be in the middle of the hole on that side, and on that side you want to make sure that you find the shorter distance. Once you're good like that, shorter distance would be the right spot. So the idea is to and once you got it, you lock it. Not the way I did. You just pull it up. You just do like that and pull it out, and then you measure it with a micrometer. We're gonna use a 3 to 4 micrometer, 3 to 4 inches. I'm gonna make conversion after, because obviously this car is in matrix system. The idea is to measure, we will call this the y-axis. I gotta measure 3 different height, so maybe that below the maybe ½ inch below the top, middle of the stroke, and close to the bottom. Normally if you look at it, you should be able to find out where it's the it's hard to see, but we can still see the maybe it's hard for you to see on the camera, but I think yes, we can see the crisscrossing of the finishing on it, and we don't even feel the ridge. So this engine wear out very well so far. So maybe the compression issue that is low, maybe it's just a matter of the yeah, I don't feel nothing with my nail. Maybe it's just the piston rings that were wear out or sticky or something, I don't know, but we will measure, we will figure it out. So again, the idea is to measure on the y-axis 3 different level, and the x-axis 3 different level. We do that for each cylinders. Inspecting the engine components, we can see there is a bit of fog, just a little foggy on the main bearings. This is no big deal. So it's not very bad, it's just a bit foggy, which is mainly where they were the crank was being actually bare. So again, this one here, we can see it's still a bit foggy here. So no big deal. So of course we're gonna replace all of those. When you measure the piston diameter, you gotta take it from that edge, 15 millimeters in, which is about ½ inch, which is about here. So you take it from side to side. This is where the piston has been guided in the cylinder. So you need to measure it from both ends like that with the micrometer. So the pistons are great. Nothing is really wrong. The only thing that seems to be wrong with the engine was the in the end was the probably the compression ring that wear off, because the cylinders are very good. I'll show you later on. The coating here is supposed to be black, and it's starting to fade away. This coating, I think, is a bit hard, and it prevents the wear of the pistons. So since I'm there, and since most of it is good, I'd rather change the piston as well. So they last 10 years and it was doing very well, so I might as well get this behind me, so I'm gonna be sure that I'm not gonna have to have an issue because I didn't change the piston in time while I was there. So this is how it looks like underneath the head. So it's not so bad. There's just this cylinder, which is the third one, which is a bit full of oil, but it's possible it was a spark plug that was loose and the oil got in the chamber. That's possible. We're gonna be able to confirm that looking at the head gasket to make sure there was no crack or anything. But compression was good, so yeah, if you look at all of those, they're not so bad, beside that one here. Doesn't look like a 10 years old car. So if we look at the valve, it is It is very nasty in there. That's gonna need some cleanup, obviously. If we look at the exhaust side, it's much cleaner. It's dark, but it's not as gross and wet as the other side. So it's still it's good to be. It's gonna be a good thing to clean it, but it's much better. This big part here is the front end, because it's a bit sophisticated, because you got the channel for the Vanos, the oil channel in there. It's like the grooves you can see. It goes around here. So one of the things that needs to be checked is if we remove the cam. Let me do this. Just want to check here to make sure, because here on the Vanos, for the Vanos system, you got kind of rings. I don't know if you can see. There's a ring in the middle. It's a middle ring. This ring tends to make grooves on both sides, where its mission is to provide some sealing. So we can see there's some wear here, because it lost its shine. So the idea is going to be to make sure that it just lost the shine, but it didn't groove. So hopefully this is what happened. Else, Houston, we have a problem. So the best way to do so for a first step investigation is to wipe it off and just try with your nail and see if you feel any groove. It's not so bad. If there is, it's very thin. Yep, I think I'm lucky. This is not so bad. So I ordered some rings which are composites, and I'm gonna remove those and try with the composite ring. That might prevent the surface to go bad, because I don't think it's going to be able to go another 10 years with metal rings like that. What happens sometimes is when you go high RPM, or if you sustain RPM, you can feel like a loss of power. That might become from that ring if the oil bypass here, or that might also happen with the turbos when the wastegate is bushing is wear, and the wastegate is tilting open, so it allows the turbo pressure to bypass. So it's one of the two that can make that. Oh, I see lines there. I don't like the lines there. Okay, so to remove the rockers, it's quite easy. It's just, in fact, there's a clip in there, but we don't wanna take it off the clamp. So it's just a matter of go gentle, and there's a pin that slides. It's a bit snug with the oil, so it's kind of fitting. So the head's been cleaned. I bring it to the machine shop. They have a machine to wash it, and it's the easiest and most efficient way to do so. It's gonna be some more polishing to do, like there's a bit of a few black residue that's still left. So that's gonna be addressed a bit later on. Now I just want to check the valve play. When I look at the information available, it says it cannot be measured, because normally you would like to put like a magnet base with a dial indicator, but obviously all is in aluminum. If we really want to do it, we could put like a steel flat bar and clamp on it or whatever. Machine shop says that the normal play would be like 5/10 of an inch, 0.005. It's hard to measure, but you gotta shake, the valve's gotta be slightly open, and you gotta shake it that direction and also that direction to check what kind of play you have. So on that direction I have slightly more, and in the other direction it's probably 5 or close to it. What I did is I pushed it all the way that direction. Also I helped with my hand on the rear, grabbing the valve stud and holding it in place. Try to measure the gap and then close it. Try to measure the gap also with a reference point like the circle, the arc there. Seems like it's about 1/8 of an inch, so it's a bit too much, but it's gonna be fine. Not too concerned about it. It's the head is not a pain in the ass if it's need to be removed in the future. So what I did, since it's a bit hard to measure, I keep that one in there and I check the others, and I can always have this comparison of that one to see how it goes. So I check all the exhaust, then I'm gonna go and check all the intake ones. So that's what I'm doing right now. It's a bit hard to try to figure it out just by moving. So even though it's not the perfect setup, I'm gonna use a dial indicator. The idea is that thing is measuring the distance that this thing going inside and transfers it into a dimension, which seems very obvious, but the idea is that we have to make sure that the angle of it is straight, because if it's in an angle, it's not gonna measure the right thing, because it's gonna measure a diagonal instead of the right axis of movement. The other thing is we have to make sure how we are, make sure that it's in the axis that the valve is moving. So that's one of the first thing we have to do. The other thing is the valve is very thin. It's very thin in thickness. So we have to, we're gonna have to move the valve in and out slightly, and we're gonna check what's the peak we get on the indicator. Okay, so these are the things to take into consideration. The other thing is the valve play on that axis is greater than in that axis. So what I'm going to do is I'm going to move the valve fully that direction. I'm going to measure this one first. Then I'm going to, once I have the proper reading, I'm going to know that, because the needle is going to move. It's going to do something like that. It's going to move and then it's going to go back. So at the peak I'm going to stay there, and then I'm going to release it, and then I'm going to play again. That's the best way that I figure out to do something like that. So if I check it, so I got about 20 out. The setup is not very rigid, so it's possible that this is moving and the cylinder head is moving, but it gives a bit of an idea. Yeah, the cylinder head moves sometimes. Yeah, it's about 20 out I have. So it's a bit big of a gap if I judge based on that 5 thou dimension that they suggest at the machine shop. So I'm gonna give a bit of thought on that thing to see if I'm gonna send it back or just reassemble it like that. They're gonna be in holidays for 3 weeks now. That's one thing that bugs me a bit, in the sense that I'm eager to put it back together, but it might worth the wait. I'm gonna figure it out. Okay, checking the valve on the intake side, they're doing, the feeling of them is very good. Very limited play on them, and of course it's not a very strong setup. The head is moving quite easily, and this is not ideal also, so, but it's just to compare both sides. And just trying to show you. Here I can read almost 20 total, maybe not, maybe like 15. Yeah, it's about 15 that I read. Right than there is on the intake, but when I look at the feeling of it, both sides, it's very limited. The intake bushings for the valves are very good in the head, which makes me wonder if that plate that is a bit bigger on the exhaust is not because of the heat expansion. Anyway, just want to show both sides how it goes with. As I said, the measuring technique is not very good since everything is moving. It's just to give me kind of an idea. Ideally would be to have the head on a very still flat surface and have the magnetic base clamped. That would be the best setup for measuring the plate, but we don't have specs, so in the end we're a bit in the dark, but just gonna think about this, and I'm gonna let you know what I'm gonna do with it. This is a good practice to look at the head gasket to see if there's something that is not right on it. Like here we can see there's some of the sealing missing. So it could be that it was cracked, or it could be that it stays stuck on the engine block or the cylinder head. So normally that's the kind of thing we want to go through and look around, especially to see like if there is any gap in between the oil passages and the coolant passages. This is a bolt, so we want to do that on both sides of it. That's one of the inspection we want to go through. I'm not too concerned about that one though, because the compression on each cylinder was about the same. So if there would have been a big difference on this cylinder, which is the gearbox side, transmission side, then that could have been a concern that that was the issue. But it's more probably that is the gasket that was stuck to the other engine block or cylinder head. The snap ring that goes in there, the beginning is right here, high above, okay, and it is like that on both sides. So the ring opening goes on top of the piston. So this is the way we're gonna have to put them back together. So we just need to remove one of those, just like I did with the brand new pistons on the other video. Wear goggles, safety goggles, because this thing is popping crazy. Oh, it's a bit harder when there's actually a pin in there. I use a hook like that. So there it goes. We just need to remove one of those. push the pin out. Then that's something that I should have done earlier, but I'm gonna do it right now. The old pin's gotta get out. It's gonna stay with the old piston. There's no way we're gonna use that. There's new pins coming with the new piston. I'm just gonna slide it back in. So what I want to do now, and as I said, I should have done that earlier. It's the checking for inspection of the engine. Gotta check the. There's a. It's a bit hard to see, but there's a bushing there that it's. I don't know if you can see, but there's a. Yeah, you can see there's a. You can see it's like a golden color. A very thin line, so it's a bushing that it's press fit in there. So I have to check that bushing dimension. So I'm gonna have to look. I'm gonna look into dimension. I'm gonna take this dimension that way, and I'm gonna take it that way. Need some cleaning. So brake cleaner to remove the oil in there. Okay, then remove any leftover debris. Make sure it's very clean. I'm gonna call this dimension in that direction, the dimension like that. I'm gonna call it the Y dimension, and this one I'm gonna call it the X dimension. And you have to make sure that your micrometer tips are clean. After that, you gotta make sure that when you go to 0, it actually goes to 0. If you're not used with that, it's better you use the clutch at the tip. If you're very used, like you took more than 100 measurement, let's say, you might wanna get a feeling a bit more. You don't over torque these things. I would say it's pretty much aligned. It should be the smallest dimension you can get in the end. So this is 869, so obviously it's too big. Because I say the smallest because if you're inclined like that, you're gonna get larger dimension. The only way that the smallest dimension is gonna be wrong is if you're off like that, which is very unlikely. That one feels right. Okay, so this is 866. $866.5. Okay, let's check in X. So this is how it goes. So on. So I'm going to take all the dimension and tell you what I found after that. Okay, I was saying that the smallest dimension that you get is the one that is right. You just have to be careful though for one thing. When you torque the this bolt to lock your dimension on the telescopic gauge, it's possible that you're gonna turn the telescopic gauge inside the hole. So by doing so, it's like you move it sideways, like you move like that. So you got to be careful for that. That can give you a smaller dimension, and then this one is obviously not the right one. So once you're done with taking your dimension, if you're straight, not like that, but if you're straight, it shouldn't be loose. So if you feel like it's loose, it's probably because when you torqued it, you turn inside the hole like that. So therefore you're smaller. So when you go this way, it's becoming loose.